And then here now we are going to discuss on terminologies in LR parsing. So in LR parsing, what are the various terminologies that we have? Um, so you must know. So here we must know how a parser knows as when to shift and when to reduce. So how it must know as when to do these action as shifting actions or reducing actions. So this is going to be an important thing here. So here based on the things like how to choose the handles and among the sentential forms, which particular string we are going to choose, and how we are going to reduce our shift. So based on that only we used to make the shifting actions or reducing actions. So LR parser which makes shift reducing decision by maintaining states and keep track of where we are in parsing phases. Either we are in an in between the parsing process, or either we are going to complete it, or what are the remaining parsing process that we have. So all those things we have to concentrate. And then here we have important terminologies like states and then items. So what is meant by items and what is maybe states? So based on these things only we used to decide either we have to shift or either we have to reduce. So the parser which used to make the decisions either it have to shift or reduce based on these two things only, states and then items. So states in the sense the set of items whatever that we have we used to call it as states, and then each and every component in these states we used to call it as an items. For example, here I have given a production in this presentation in this slide. Example, the production which A gives the arrow dot xyz. So this is going to be the first item that we have over here, and then second item which is going to be A gives x dot yz. So simply I am going to move the dot from the left of x to the right of x. Okay, and then the third item that we have over here is A gives x y dot z. So from the left of y I am going to move the dot to the right of y, and then the last fourth item which is going to be x which gives x y z and dot, and then now I am going to move that particular dot from the left of z to the right of z. And then after this only, after this movements of dots only, I am going to convert this xyz into a. Okay, and this movement of dots from left to right actually which is like shifting process, and then after completing all those movements, converting xyz into a we used to call it as an reducing process. Okay, so when we have to shift or when we have to reduce, which is based on whatever the productions that we have. Okay, so this is about the productions that we have over here. So in this productions we are going to have some a group of four items, each and every component. For example, a gives dot xyz which is going to be in first component, and then a gives x dot yz which is going to be in second component, and then a gives x y dot z which is going to be in third component. Like that we have some four components, each and every component we are calling it as an items. Okay, so this is very important. So parsing process which used to make some parsing decisions based on items and states. And then next one which is about G and capital G. So you people know about G means which refers to grammar, and then G dash which refers to augmented grammar. Okay, so normally in construction of LR parsing table we used to use grammar alone, while in the construction of canonical LR parsing table we used to use G dash augmented grammar. So that's going to be difference between G and G dash. The next one which is about C and C dash. So C which refers to uh, collection of items, and C dash which refers to canonical collection of sets of items. And then So these are the differences between G and G dash, and then C and C dash. And then you people must be very clear the construction of LR parsing table, and then construction of SLR parsing table, and then construction of canonical LR parsing table. Moreover, in all these constructions, whatever the procedures or steps that we're going to follow is same. The only thing is whatever the entries that we're going to made into the parsing table alone, which is going to be an different one. The next, this is going to be a final topic in the session, the construction of canonical LR parsing table. The rules for constructing LR parsing table and then canonical LR parsing table, as already told, which is going to be the same. There won't be much differences in construction procedure, but in the table entries alone you will have some differences. That's the thing that I already have stated you. And then algorithm, so algorithm, which is very important. So whatever the algorithm that you're going to use in compiler design, in this algorithm we have some three processes as input, and then you will have output, and then you have method. So input in the sense, what is the thing that we are going to take as an input to this parsing process. So here an augmented grammar G dash, which is going to act like an input. So here we are going to construct canonical LR parsing table. So we are going to use G dash. At the same time, suppose we are going to use just construction of an LR parsing table, that we have to use just G which stands for grammar alone. So that's going to be difference. And then output, so output which is going to be the parsing table, but whatever that we're going to construct, which is going to have some functions like action and go to. So you will have some table, and then whatever the action that we're going to perform, that will be mentioned in that particular table. And then the continuation of this method. So here, um, so these are the methods that we're going to use for construction of canonical LR parsing table. So you must know what is the input, and you must know what is the output that we're going to construct, and in between this input and output, whatever the methods that we're going to follow is very important. So in the first step, I have given as C dash equal to I0 comma I1 up to IN for G dash. So first we must know what are the collection of or canonical collection of sets of items that we have. So starting from I0 till IN, so whatever the item sets that we have to use all those item sets. That's very important. We must not even miss a single item sets in this conversion process. So that's about the first one. And second one, which is about action, shifting action. So while moving the dot from left to right, we used to perform the shifting process. So similarly in productions, while applying productions, we used to convert a start symbol to non-terminal, or non-terminal to further as a non-terminal, and then non-terminal to terminal. So these are the processes that we used to have normally, or else and non-terminal to start symbol, or terminal to non-terminal. So like this we used to move. So in bottom up parsing process, we used to move from terminal to non-terminal, and finally non-terminal to start symbol. So these are the movements that we have. In these movements, the second action that we are going to perform here is about shifting, and then third, which is about reducing in the sense, soon after completing all those conversion process, we used to move from the component to particular non-terminal or particular terminal. So these types of movements we used to call it as a reducing process. For example, A gives xyz dot. Here we are going to take the xyz, and then we are going to convert it into capital A. So these types of conversions we used to call it as an reducing process. So the second action, which is going to be in shifting, and third action, which is going to be in reducing, and then fourth action. So here we used to mention the start state as initial state as s dash. So here we are using augmented grammar as G dash. So here we have to mention the start state or initial state as S dash. So in canonical collection of construction of LR parsing table, we have to use G dash for to refer the augmented grammar, and then S dash to refer the initial item or start item. And then see here, if S gives S dot, so during the starting up of parsing process, the dot will be to the left of yes. Then after completing the process, the dot will move from the left of capital S to the right of capital S. So whenever this dot move from left to right, which denotes we have completed the parsing process, and which is about accepting. So accepting in the sense we have completed the parsing process. And suppose if there is going to be any conflict actions above the four steps whatever that we have, we used to call these as an error. So algorithm which is going to be fails to produce some LR parsers, which results in error over there. And then the next step, so during this transition process, normally we used to use an function named as an go to function. So using this go to function only, we used to convert the non-terminals to further non-terminals, or non-terminals to terminals, or non-terminals to a start symbol. So these process will be performed by go to transitions. So we have to follow all these steps, or else it's going to be results in error. And then here we are going to use the initial start state of the parser. As already told, the dot will be to the left of capital S. So S gives, S dash gives dot S, which is going to be an initial parsing process, initial state of the parsing process. And then what is the table that we're going to construct? We used to call it as an LR parsing table. And here we have to mention these four important things. What is the parsing table that we're going to construct, and what is the automaton diagram? So automaton diagram which shows the movement, like the parsing process, shifting, or reducing, or accepting. So all those three important movements will be shown in your automaton diagram. So that's very important. And then production in the sense what are the grammar, CFG, context free grammar, that we're going to use. So we have to use, or we have to list out those productions. That's very important. And then next one, it is about LR parser diagram. So LR parser diagram in the sense you will have an input, and you will have an output, and you will have some sets of items, and then you will have the functions like action and go to, and then the output which is going to be parsing table. So like that you will have a diagrammatic structure. So you have to include those things. So these are some of the important points about LR parsing techniques. So so here you people have to keep in mind what is meant by parsing process, and what is meant by SLR, and what is meant by SRP, and what is meant by items, and what is meant by states. And then for construction of LR parsing table, and construction of SLR parsing table, and then for construction of canonical LR parsing table, for all this construction, the actions are the procedure whatever that we're going to follow is same. The only different thing is whatever the table entries that we're going to make, that alone which is going to be an different one. So those things people must keep in mind. And then what is meant by S dash, and what is meant by G dash? S dash which refers to the start state or initial item of your augmented grammar, and G dash which refers to augmented grammar. And then the tool, so normally we won't able to derive it in hand. So normally we have to use what, we have to use some tool like automatic parser generator. So using this automatic parser generator only, we used to construct an LR parser. So these are some various important points which is relevant to this particular topic. So these are some important questions that they normally used to ask in university questions. So concentrate on these topics. So thank you for listening, students. So with this, we could stop this session, and then suppose if you have any doubts, you could ask me now.